Good morning, e-learners. All right. Same drill. It's Tuesday, or for us it's Tuesday. It's Wednesday for you guys.
I swear.
I was going to say that I forgot my lunchbox downstairs, but I don't even have any shit. I ate it all. We did benchmark for.
Well, if you eat all your lunch during gym, you're going to have a long, hard lunch. Just remember, hey, that's our emergency water source. You can have a little bit, sure. Yeah, that's our emergency water source. So if we ever have to run out to the desert, I don't know, we're all in trouble. All right, I need everyone to stop talking and listen, please. Okay, so I will readily admit that the section that we just did is, and I said it yesterday many times, it's one of the more challenging ones we did. Problems come in two flavors, if you notice during the homework. The two flavors, I don't know, we call them vanilla chocolate, but the vanilla one is where you're adding two things together. You're adding two unknowns together, and you're told that they total, they sum, all together, you have something. So the first one, we'll call it flavor A. You're adding two unknowns together, and you're actually told what it equals. Hey, she's got 4 more than me. I got triple the other person, and together there's 196 all together. That's the one that looks like this model right here. The second one, the chocolate one, which is the harder of the two, never says all together you have anything. It simply says you might have 4 more than her and 6 times the other person. It never says all together. So the second model is the one that looks like you have some value equal to some other value. Of the two, which is the harder one to figure out?
Chocolate.
This one. So I will put this one on the test. What, today after tomorrow? I will not put this one on the test. So the one that you will see on the test are the ones where it says altogether they have 196. It is the easier of the two models. We still need to learn this, right, the second one, but I'm just to assure you so that you're not in complete panic mode, right? You guys were never in panic mode, and then we got to this section, it's like, whoa, I'm really struggling with this stuff. So I do want you to rest assured that I will take care of you. We're going to learn both models, but I will only test you on the model that says all together. Yes, Josie.
So, do we have to make the equation? Because I don't understand how to do it.
There is occasionally, if the numbers are really friendly, you can do some guessing and checking, right? Come up with the right answer. Occasionally. Most of the time, though, it doesn't matter. You can't do a guess and check.
Well, I didn't just guess. I don't know what.
Remember, they give you 3 possible answers, so it's not like it's even a hard guess, right? They're going to give you 3 possible answers. And you can just kind of if you're like Josie, she's kind of on it, and she could say, well, it's already telling me it's got to be 18 more of this one and then triple the other one. Yeah. You can kind of rationalize what the answer is. If I didn't tell you what the answer was, well, then the only option we have are the 2 models. I will say this, the Model A right here, we will see this so many times this year, right, that you will become very comfortable with it. Yeah.
I just need help with making an equation.
Anna's got the first one. Which one, Anna? I'm going to leave that up there. Let's take a look at number 4.
Okay.
It says one number is 4 times another number. The larger number is also 87 more than the smaller number. Find the numbers. Does it ever say in there, together they total 432?
No.
So this is going to be the harder of the 2 models. So the harder of the 2 models start with an equal sign. Notice, when we do this one, there will always be a big number and a small number. Sometimes it literally will tell you, it says it right here. Other times, you got to tease that out from the information, which number is big or smaller, okay? So on number 4, it says one number is 4 times the other number. So I'm going to put big, small. Right? Big, small, big, small. The larger number is also 87 more than the smaller. So is it telling me about the larger number, or is it telling me about the smaller number? The larger number is 87 bigger than the smaller.
The larger number.
It's telling me something about the larger. Therefore, I know nothing about the smaller number. That's my x. See where I'm getting that from? It tells me something about the larger number. It's 87 more than the smaller. I know nothing about the smaller. So x for the small, the big one is 87 more. So how do I write that?
Plus 87.
So not plus 87, x plus 87. Why x? Because we just defined the small number as x.
Wouldn't it be 4x?
Well, I only did one statement. We're about to get there. Hold on. We okay with that? The first statement, the one that she was like, she's already jumping to the answer, gives us another bit of information. It says that the bigger number is 4 times the smaller. Now here's where I tried. We did 2 of these. This is where you get into big trouble. No pun intended, because we're talking about big number. The problem is this, and I said, and then I went on this tangent. I said, hey, just pick some friendly numbers that are divisible by 4, like 12 and 3. Do you agree now that the big number is 4 times the smaller?
Yep.
But what does that say right there?
Equals.
Is 12 equal to 3? And you can't answer any more questions. Okay? Is 12 equal to 3? And you're like, where did you get the 12 and 3 from the problem? I made those numbers up to help me wrap my head around the problem. Because the statement says what? The first statement?
I don't know.
It says that the one number is 4 times the other number. Do you agree that now I have this set up so that one number is 4 times the other? And clearly the one that's 4 times bigger would be the big number, yes? But here's the problem. This says equals. 12 does not equal 3, but we can force it to equal 3. There's 2 ways to do it. One through division and one through multiplication. If we want to use division, which number are we going to divide so I can put an equal number? If we want to use division, which number am I going to divide?
3.
So you're going to divide 3 and it's going to be equal now?
I'm confused.
12.
I want this to be a true statement, equal.
Yes.
Is it a true statement right now?
No.
We know one is 4 times bigger.
Yes.
So I have 2 options.
So you divide 12 by 3.
I could, right? If I divide this number by
3.
4, right? 'cause
I'm
it's
very
4
lost
times.
right now.
Do you agree now their 2 are equal?
Yes.
So if I divide this whole thing by 4, now they're equal. Okay? That's option number 1. Does anybody like that option? Divide by 4? What's the other option?
Multiply by
Where are you getting 4 from? He just made it.
Where am I? What's that symbol say right there?
Equals.
Are they equal right now?
But where are you getting 12 and 3 from?
Okay. I'm gonna start back from the beginning. This time you gotta listen. Right? I gotta wrap my head around this thing 4 times. So how do I do that? So I made up 2 numbers.
Yeah.
One is 4 times the other.
Yeah.
Why did I do that? It's just a wrapping my head around the problem. I wrote 12 and 3 and put them equal to each other.
Yes.
Why did I choose 12 and 3? I could have also chose
Because they're divisible by
2 and 8 because the bigger one is divisible by 4, right?
Yeah.
And the reason why I'm doing, and this is not a required step, by the way. I was a teacher thing of trying to get you to wrap your head around which number do we want to either multiply by 4 or divide by 4.
Yeah, I understand, but I want.
And oh, by the way, you already told me the true answer. You're already
I
finished
know,
the problem.
but I know how to do it without doing the equation, but I want to know how to make an equation.
Yeah, and that's what I'm trying to show you right now. Is you have to figure out how to handle that statement. One number is 4 times the other one.
Yeah.
So in my thought process, one number is 4 times the other. That means one number is really big.
Yeah.
Well, it's got to be this one, right? Correct?
Yes.
But I need them to be equal.
Yes.
8's
So-
not equal to 2.
Yeah, so you divide by 4.
Okay. If I divided this 8 by 4, would they now be equal? So if I divided this thing by 4, would they now be equal? Same reason. That's the logic.
Okay, so but what number? The 3 numbers that you're given, you just put it into the x.
Stop right there. Stop right there. Right, the answer is yes. Right? Now I just got to make sure I don't lose anybody. Now, I started this by saying there were two ways of doing this. We can divide by 4, or we could have.
Multiply by 4.
You tell me which one you like to do more.
Multiplication. So you would put the number in there and then you would multiply by.
But I do want you to notice what it says. It says one number is 4 times the other number. Well, the number that's 4 times is the bigger number. So the mistake that I typically see students make is they'll put the times 4 on the big number, because it is 4 times the smaller one. But it ends up being you're putting the 4 in the wrong spot. Okay, so I'm not saying that you can't do the division. You can. I'm just saying most of us would probably be more comfortable with this. Anna, this was your question. Are you with me or you're not with me? Okay, so Josie said, well, the next step would just literally, so do I just plug the numbers in and see which one works? The answer is yes.
So wait, but would you put, so what are the choices? So say you put 29.
Let's put 29 in. What's 29 plus 87?
I don't know.
116.
But I thought you were putting the number into the small number, not the.
Oh, I have 2 X's.
Oh.
And what's 4 times 29? It turns out to be 116. Boom, it's done. Okay. Which flavor is the hard one?
Division. That's what I did.
Right? This is the easier of the two. This one, it's literally, you read it, you write what it looks like. Right? All right, anyone else? That's worth the effort of going over a few times. Right? Okay. No one else? Yeah. So for instance, number 6. 6 is ugly. It's got ugly, ugly, ugly numbers.
This one was so hard.
All right. It says a clown weighs 60 pounds more than a trapeze artist.
Hey.
So apparently you got a fat clown, right? Or a skinny trapeze artist. Trapeze artist weighs 2/3 as much as the clown. How much does each weigh? Are we told all together their weights add up to this?
No.
So we're back to the hard one. You got 2 people, trapeze artists and clown. So C for clown, T for trapeze. Which one weighs more than the other? So I'm going to put little b for big and little s for small. This is one of those equal models. All right, one statement at a time. The clown weighs 60 more than the trapeze artist. Which one do we know nothing about?
Trapeze.
Trapeze artist gets the x, and the clown is what? It's not that I don't want you to answer, just that everyone else, I just want to make sure. You absolutely got this. All right. It's the second statement that makes our life really ugly. It says that the trapeze artist is 2/3 as much as the clown. You really, 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 really want to put the 2/3 on the trapeze artist. It's not. It's that same problem of they're equal. It's that you put the 2/3 on the other one. Okay? So multiplying by 2/3, right, would take 2/3 of a number. All right. What are our 3 options, or what? 110, 120, 125, yes? All right, so, oh, by the way, which one are we multiplying by 2/3? Okay, so I gotta multiply this by ugly numbers, 2/3. Why did I put it on here? Because it says the trapeze artist is 2/3. It was the same thing as the big one was 4 times the other one. I'm gonna go back to 2/3 is not a friendly number. We use friendlier numbers. Going back to the big and the small, and I said that 12 is 4 times 3. I don't multiply the big one, I multiply the small one, right, to make sure that they're equal. This time, we're not told that the clown is 2/3. We're told that the trapeze artist is 2/3. So I don't multiply the trapeze artist, I multiply the clown by 2/3. It's the opposite of what you would think. That's the only way we can get them to be equal. That's ugly, but it does tell us the numbers. By the way, what's the answer? So that I don't have to do this.
180.
Is it which 120, right? Okay, so 120 ends up being the one. Let's see how that works. So if I plug 120 in, right, anywhere I see an x, what's 120 plus 60?
180.
What's a third of 180?
120. Well, a third of, no, 2/3 divided.
180 divided by 3 is,
60.
times 2 is, okay.
Or could you do x plus 6 equals 2/3 x?
No, that won't work. Try it out. Plug in 120 and see if the two are equal. It won't work. Right? This is the only way that works. Aren't you glad I'm putting this model in?
Is there any way you could do multiplication with that one?
I did do multiplication. I multiplied it by 2/3. If you want to put it on the other one, this is going to get crazy. Remember, you can either multiply by 4 or divide by 4. We would need to divide by 2/3, which would be the same as multiplying. I'm not recommending doing this. You'd have to change this to 3/2. It's the same thing as multiplying by 4 is the same as, I shouldn't say it like that. When we were setting the two sides equal to each other on the previous one, we had the choice of either multiplying 1 by 4 or dividing the other side by 4. Same thing here. We either could multiply by 2/3 the clown, or we could divide by 3/2 the trapeze artist. That would be mathematically the same thing.
I don't know how I got the answer to that.
Well, you can always do a guess and guess correctly. How about we do one of the easier models so we end this on a positive note? We're all a little bit more comfortable and happy, since that will be what will be on the test. All right, somebody look at the problems. Which one is model A? Number 4. Number 4 is not.
Number 2?
Number 2. Nope.
No.
2 and 4 are good. Number?
10? No. 8?
Nope.
Number 8? No, 8 does because there are 4.
Number 8 is one of the few. They're like that. I'm going to claim that number 8 is easy. Let's see if I'm right. It says the 9th grade class has 17 more girls than boys. There are 431 students in all. In all. As soon as you heard that word in all, you know that together, boys plus girls equals in all. Yes? Right, so it's that model. How many boys are there? How many girls are there? All right. So the 9th grade class has 17 more boys than girls. What's the only thing we don't know? The 9th grade has 17 more girls than boys. What do we not know? We don't know how many boys. So guess who gets the variable? Boys, we'll put G for girls, B for boys. So boys get the X. What do we know about the girls? There are 17 more. So how do I write girls? X plus 17. Now stop me. I could not do that all by myself. It's just one sentence. There are 17 more girls than boys. Clearly, I don't know how many boys there are. There's X. Then if you add 17 to the number of girls, you get how many boys there are. Did I say that backwards? Yes, I said that backwards. There are X number of boys, but there's 17 more girls than boys. So if I add 17 to the number of boys, I get how many girls there are. Because there's 17 more girls than boys. Okay? All together, they equal
431.
431. What do I do here? Could you do this one by yourself? I'm just going to say, any scenario that I make with this particular model, it's the same thing. It's almost the same wording. This is the one that's easier. That's the one that will be on the test. You're given 3 values, plug one in, see which one works. By the way, which one works?
207.
But what does the question actually ask?
How many boys?
How many boys? How many girls? So boys equals X, and you said X was, what was it? 107, 207? Girls would be 17 more than 207, so 234. There you go.
234.
All right, 17 plus 224. Plus 1. Plus 1. Very good. All right.
It was like 49 minutes.
We good?
Yep.
All right, how many people, at least since I said this will be on the test, are okay now? I mean, you're okay, or you're still panicking? I'm not panicking. I'm okay.
Okay.
There's only about four hands in the air. So sometime between now and the test day, which is Thursday, Friday, We got to get to where, how about every day we do one of these as a practice problem at start of class?
Yeah.
Okay. All right. Sounds good.
I just made
We will do that.
He wants to give it your.
Yeah, so let me call out the answers real quick. Number 2, the auditorium is 28 and the gym is 7. Number 4, the smaller number is 29, the larger number is 116. Number 6, the skinny dude weighs 120 pounds. That's a skinny dude. And the clown weighs, I'm being, what do they call the term now? You wouldn't say sexist, racist, you say weightist? I shouldn't make judgments on people's weights. All right.
Body shape.
Body shape, that's the word I was
Body
looking
shape.
for. Yeah, I knew there was some fancy word now for it. All right. The clown's 180 pounds.
That's okay.
Number 8, the boys, 200, we just said, boys are 207, girls are 224. And number 10, the last one, Southern is, and Western is.
30.
How did you get that right? I didn't do that one for you.
Well, I just made it a lot more complicated. Like I could do it, but I made it a lot more complicated than it needed.
All right. I'll just say, when they give you 3 answers, you can do a good guess and check and just make sure it's rational. It meets the parameters. You can.
It just took.
All right. Aiden, do me a favor, grab an empty basket over there. No, you're going to grab the one that says Algebra-1 in it. It's got the Algebra-1 papers in it. Yes? One of them better say Algebra-1. All right. One of you pass out, the other you collect. All right. Hey, after a hard class like that, wouldn't it be nice if we had an easy day?
No.
You're not gonna give us one, are you?
Yeah, it's an easy day.
No, it's not.
Yes, it is.
Give us
Nice.
one. Hope so.
All right. Copy down your homework.
Well, that's a lot.
It is an easy day.
What if it's not though?
No, I'm not lying.
Plus, it wouldn't give us this much. I'm sorry.
I don't
we
trust you anymore.
It wouldn't give us this much.
I'm not that bad.
Yes, you were. Last year was horrible.
In what way?
No, that's not my age.
Like, when did I ever lie to you last year?
Josie, how many times did he lie to us last year?
I lied to you. When? Name it.
Every single time you said
Well,
that class was gonna be easy.
I said the class was
I
what?
didn't say you lied to me. I said I don't trust you.
And it was super easy.
Oh, okay. So, yeah,
You know, like winnings in the
there might have been
lessons.
some motivational
It's
things I
hard
did.
for you guys.
I'm clicking the numbers. I'll give away all my secrets. I clicked.
You clicked. No, because like you say things today, and then when we get halfway through the lesson, you're like, some of it, you might struggle. What is it?
Okay. No, I think none of you will struggle with this today. Well, I'll ask you at the end of class.
Might as well be.
Is that the homework?
That is the homework.
That's too many problems.
So therefore, if I gave you that many problems, oh, by the way, how many problems is that?
24. What? Wait, no.
It's either, what, 23 or 24? I don't know. Count.
23.
You have to divide 46 by 2.
Yeah, I got 23. I got to the best.
Yeah.
I said 24. I know.
Make that.
Don't believe. This makes no sense. That's the first order that comes out of
How about we wait 5 minutes?
Yes.
See how they're not.
Well, he hasn't explained it to you yet.
All right. So my claim is that this is easy. Quiet, please. My claim is this is easy. I will say, I don't think there's anything in there that, if you were paying attention, if you had me as a teacher last year, that we didn't use. There's 1 or 2 new vocabulary words, but they're really simple. Okay. If I was not your math teacher last year, there could be a lot of stuff here that you haven't seen. Big picture, it's not bad, but you do need to take some good notes. All right, here we go. Numbers on a line. Literally, we're going to be doing number lines today. That's it. All right. Okay, so this is 100% for those of you that had me last year. We've done this before, so this is background knowledge. You've had it in the last, say, 2 years or so, and it is absolutely positively critical that you've mastered this, so that we can do well this year. All right, so let's talk about numbers. I mean, just numbers. The first word I'm going to give you is something called a set. A set is like a bag. And in this bag, we're going to put numbers, right? And these bags are going to have names on them, right? I'm going to put only specific numbers inside the bag, right? There's going to be rules. Like, we don't like you, you go over there, but these numbers, we like you, you go in the bag. The bag is going to have a name. This is the concept of sets in math. A set is just, write this down please, a well-defined collection of numbers. Well-defined means there are rules. You don't get in the bag unless you meet one of these stipulations or rules. You're a negative number, you're too negative for me. I only want positive numbers in this bag. So you go into another bag. But positive numbers come to my bag, right? It is discrimination. It is 100% discrimination. So this is called sets, right? Sets, plural, set, singular. A set is one bag. Sets is more than one bag. All right, the next word. The numbers that go in the bag, right? We just don't call them the numbers that go in the bag, or math, we got to give them different names. We call them elements. Element is a fancy word for one of the numbers that goes in the bag. So if I got the bag of positive numbers, right, then the number 5 goes in the bag because it's positive. So we call 5 an element of the set of positive numbers. The bag is labeled positive numbers. 5 is in the bag. So therefore 5 is an element of that bag. Okay? Okay? Now, if I have a bag of positive numbers, are the even numbers in that bag? Right? I got a bag of nothing but positive numbers. Are the even numbers inside my bag? I could take all the even numbers and put them into a smaller bag inside my larger bag. Guess what we're going to call that smaller bag? We can't call it a set. We're going to call it a
Smaller set.
We're going to call it a smaller set.
Did I really get it?
Wouldn't that make a lot of sense? But mathematicians are like, nope, we're going to give it another word. We're going to call it a
Oh,
subset.
that makes sense, though.
A subset is you look inside the big bag and you pick out some more numbers that are also well defined. You give it a rule. Hey, I want all the numbers that are between 10 and 20. Get in the bag. Right? Those would be in the larger bag called the positive numbers. But we would call those a new name. We'll call them the numbers between 10 and 20. We call those a subset. So these are the 3 potentially new words for you. The rest of the class, there's no more words you should not be familiar with. As we go higher in math, next year geometry, algebra 2, pre-calculus, right, you're going to see these words, set, element, and subset a lot. We okay? All that in box 1. I'm moving on. Hey, caveman, cave woman, cave boy, or cave girl, I'm not sure which. Something like that, right? Did they have numbers? What kind of numbers do you think they had? Somebody said over there, what'd you say? They had their fingers, right? So do you think that caveman, cave woman, cave kid could count to 10? No. Well, unless the mammoth ate their finger, right? And maybe 9 they could count to. But yeah, they had numbers. Not to lie to you, guess what we call their numbers? We call them the counting numbers, right? Now, more formally, the counting numbers are called they're kind of like natural setting. They're called the natural numbers. So what's the first natural number that we have?
0.
Okay, caveman, cavewoman didn't have the concept of 0. So they wouldn't look at something and say, I have 0 rocks. Doesn't make much sense. They'd say, I have 1 rock, 2 rocks. So the counting or natural numbers start with, and then they go up by each time. Those are what we're going to call, these ones right here, ... means it goes on forever, right? So these numbers that start with 1 and go up by 1 are called the natural numbers. Write this down, box 2. These are called the natural numbers. This is how they define the set. This is the bag. This is one of the largest bags we have, right? And it has what numbers are called the natural numbers. Inside the natural numbers, there's subsets. What's a subset inside the natural numbers?
Even numbers?
The even numbers are there. The odd numbers are there. The numbers bigger than 50 are there, right? Fractions, caveman, cavewoman didn't have fractions.
Half a finger.
Yeah, exactly, half a finger, right? Woolly mammoth ate my finger.
Prime numbers?
They didn't have the concept of prime numbers, but absolutely prime numbers would be part of the natural numbers. Okay, so the natural numbers 1, 2, 3, that is the set. Sophia, give me an element of the set. of natural numbers. Give me an element of a set of natural numbers. That's a big, complicated way of just saying, pick a number from the bag. 2 is an element of the natural numbers. Just fancy words for pick a number. Give me an element of the natural numbers. 5 is an element of the natural numbers. Okay, is that complicated? Subset is, well, think of all the numbers and give me a smaller bag. Give me a smaller bag that has a defined, rules for getting inside your smaller bag that these numbers are made up of. She said like the even numbers would be a smaller bag, right? So the big bag has all the natural numbers. Give me a smaller bag. You can choose from the natural numbers. The odds, right? Give me a smaller bag than the odds. What?
2.
You could have a bag with one number in it, right? We're going to define it as equal to 2. That would be a very small bag. Ready? You can have a bag that's empty, right? We call it literally, and you will see it this year, we literally call it the empty set. You probably saw this last year. Remember this symbol?
Yeah.
What does it mean? It means nothing. It literally means there's no numbers in your bag. We call this the null for nothing set. This is the null set symbol. Okay? It's also called the empty set. Okay. Natural numbers. Along came the, oh, by the way, the Greeks didn't have 0. Neither did the Romans. What's the Roman numeral for 0? What's the Roman numeral for 0?
Numeral?
What's Roman numeral 1?
A line.
What's Roman numeral 5?
1.
What's Roman numeral 10?
X.
Where's the 0?
Nothing.
They didn't have 0. They literally did not have 0. That's their number 10. What's our number 10? We've got a 0. The Greeks did not have 0. They had a symbol that represented 10. They had a symbol that represented 100. They did not have the number 0. They only had 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, and it stopped. We have 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Kind of crazy. The first civilization, we believe, that used literally the number 0 were the Indians, right? The Indian, Taj Mahal, right? The Indians were, we believe, one of the first societies that had the number 0. Does 0 belong in our bag of natural numbers?
No.
No. So if we put it inside the bag, well, it's in the wrong spot. So it's got to go even in a bigger bag. The bigger bag that includes the natural numbers and 0, anybody know? Kind of, nope. That's a really big bag. Kind of makes the number system whole, right? So we call them the whole numbers. So if you add 0, you got to put it in a bigger bag. We call these the whole numbers. Box 2. The whole numbers are made up of the, what are these numbers?
Natural numbers.
Plus
0.
0. The whole numbers are 0 plus the natural numbers. You're like, well, all you did was add one more number, and you gave it a new name. I sure did. Notice what I don't have. What am I missing?
Negative numbers?
I don't have any negative numbers. What else am I missing? Fractions, decimals. Okay? There's one other type of number we're missing, but we'll save that for a different day. Okay? The bag is getting bigger. Well, it only got bigger by 1. Say again?
Mixed numbers going with
No, mixed numbers are fractions or decimals. Irrational numbers put together. Okay. So those are my whole numbers. We're not going to go through this drill of give me a set, give me an element. Chris, give me an element of the whole numbers. Any number that's in the bag. What? 2 is an element of the whole numbers. Piper, give me an element of the whole numbers. Okay, do we get this idea of set, element, and subset? Okay. All right. If we throw in the negative numbers, anybody know what they're called? That's the next set. Nope. Eventually we'll get to that answer, but we're not there yet. If you throw the negatives in with the whole numbers, guess what the bag is called? Nobody?
Oh.
Nothing? Okay, write this down. These are called the integers.
Oh, that one.
The integers are made up of the, say it with me, they're made up of the,
Real numbers.
they're made up of the natural numbers, whole numbers, and, well,
Negative numbers.
no, negative numbers are not called integers. Hey, take a look at -2. How far is -2 away from 0?
2.
Well, what is there another number that's also 2 away?
2.
So what are we going to call -2 and 2?
Opposite numbers.
So the integers are made up of the naturals, the whole, and their opposites. Well, more precisely, it would be 0, the whole numbers, and their opposites. That's what it's made up of. Most people say integers, oh yeah, it's those negative numbers. Well, no, it's also includes the natural numbers and zeros. So we say integers are made up of the natural numbers, their opposites, and zeros. We good? All right. So far, have I been truthful? Saying today was easy?
Yes.
All right.
I'm so confused.
Let's take a look at negative numbers. Remember, negative numbers, the first one we have of the integers, right, starts with -1, and they only get smaller by 1. Dot, dot, dot means it goes all the way down. Keeps getting smaller and smaller and smaller. Okay? Look at the board. This is the last time that you will ever see this. What's the difference?
It's higher.
Probably last year or the last 2 years, whenever you dealt with negative numbers, where did they put the negative symbol? It was kind of slightly above. That's it. Today's the last day. From now on, where will the negative always be? Right smack dab in the middle. So it absolutely looks like subtract 4. Yeah? The hardest thing for pre-algebra students and algebra students to wrap their head around is these two are the same. I don't know why. And they say, well, what's that? And I say, -4. And they're like, wait, isn't that subtract 4? And I say, yes, it is. And they can't wrap their head around. It's the same idea. Subtract 4 and -4 means get 4 smaller. Okay, so that's the last time you're going to see this. You will see this to make for homework, right? The negative will be slightly above. Just don't get don't lose your brain over it. This is how from now on how you're going to see -4. Next section in forever, the last math course you ever take. All right, we're going back to first grade. No recess though,
Darn it.
or nappy time. All right.
That was kindergarten.
In first grade, they literally made you make number lines. Today, you got to make a number line. All right. I do not want to insult your intelligence, but what must you first have to make a number line? I have to have a line. Lines are straight. They're not curved. We call things that are curved curves. Things that are straight, we call them lines. Okay. You must put arrows on the end of your number line. Otherwise, it's a number segment. Chris, you with me? Okay. Not always, but generally on our number lines, guess what goes in the middle? 0 does not have to go in the middle. Well, what kind of number line is that? If I have a number line that goes from 5 to 10, 0 is not going to be in the middle, right? What would be in the middle between 5 and 10?
8.
Let's see, how many numbers is that? 5, 6, 7, 8, 9, 10. That's 6 number. Well, there's 3 numbers. There's no middle, right? It'd be, what, 8.5 would be in the middle? Okay, so you don't have to always have 0 as the middle. Not to insult your intelligence, I will. Oh, by the way, this is box 3. The positive numbers are on which side of 0?
Right. Excuse me.
And what numbers are on the left side? Hey, like I said, I don't want to insult your intelligence, but yeah, you got to know where to put the negative numbers. Further, if I had asked you to make a number line that went from -5 to 5, tell me how you would do it. Walk me through it. What would you do? Go for it, Julie. Julie. What would you do? Your first step would be to draw what? Draw a line. Second step. Arrows on the end. Okay. Be careful with what goes in the middle. I would always recommend you start with the outermost points. Because how do you know that 0, I mean, obviously 0 is in the middle of this one, right? But how do you know? If I said go from 5 to 10, how are you going to know what goes in the middle? If you make a number line from 5 to 10, then on the left side you're going to have, and on the right side you're going to have, and then you can kind of like give it some thought and figure out, oh, what would go in the middle? In that case, nothing would go in the middle, right? Not like I said, I do not want to turn this into, really making fun of anyone in the class here, but you got to have tick marks. The numbers go directly underneath the tick marks. Yes, it's first grade, right? You're making number lines. We do this in this class because this entire year, you'll be making number lines of some sort. Right? You got to be able to make a number line correctly. All right, back to first grade. Well, in first grade, you didn't have negative numbers, but the teacher might say something like this. There is 3, kids, on the number line. And then maybe said, take your left hand and point to number 3. Now, I will insult your intelligence because you guys screw this up all the time. All right. If I asked you to graph number 3 or find a point on number 3, how do we make a point? What shape are we going to use? We're going to use a dot, right? Just so I say this mathematically correct, points have no shape. We generally use a circle filled in to represent them. But there is absolutely no shape to them. We could use triangles if we wanted to. Now, every year I see this. When I ask you to graph 3, someone inevitably puts their dots above or below the 3. Where should it go? On the line. Watch me. You see my circle? What did I just circle? I circled the tick mark. That's where it should go. Then you need to fill it in. I just graphed 3. Okay? 3 is called the coordinate, right, of this point. Right? Now it's nice and pretty. All right? The coordinate point is this red dot. 3 is the coordinate of the point. The red dot is the coordinate point. All right. Turns out for number lines that each number is paired with a tick mark, right? It's paired with exactly one number. There's not like 2 numbers that get paired up with a 1 tick mark. When you make your number lines, you don't get the option of saying 0, 1, 2, 30. Number lines don't do that. If you set the standard, we're going up by 1, all the tick marks have to go up by 1. Okay? This is the statement that each point is paired with exactly one number. Right? You just didn't pair them up if you don't go by 1s. You have to go by 1s. But if you choose to go by 2s, all your tick marks go by 2s. Okay? All right. Another quick notes. Now, I don't have you write this down. I'm not going to test you on this, but you're going to see this language in the book tonight for homework. Because negatives go to the left and positives go to the right, we call both negative and positive numbers what are called directed numbers. Directed in the sense it directs you which direction to go, right? If I'm standing at 0 and I say negative, it's directing me to go in this direction. I'm going in the negative direction. If I'm standing at 0 and it says 1,000, it's directing me to go in that direction over there. That's why we can call, not 0, but we can call these numbers directed numbers. Now, tonight for homework, they're going to have you write directed numbers. You're like, well, I don't know how to do that. Sure you do. Even without any instructions, you probably could figure this one out. Here's what it looks like. Right? The directed numbers tell us the direction and the size. If I say go to -3, you're going 3 tick marks to the left. Right? That's the direction and the size, right? Some quick examples. They're going to give you words, and they're going to say write the number. A temperature rise of 6 degrees. Well, obviously, the number that you recognize right there is what?
6.
Is that in the positive direction or the negative direction? How do you know?
Rise.
Okay, like I said, without any instructions, you should be able to pick that one up. So technically, I should put +6, yes?
No.
Mathematicians are lazy. Have you ever seen a plus for a positive number?
No.
So we write anything positive without the plus. Why? Seems kind of arbitrary, and it is. Literally. Some guy said, I don't want to write pluses, right? If I leave off the plus, it means it's positive. Literally. Somebody made that rule. Same rule doesn't apply to negative numbers. A temperature drop of 8 degrees, we must write as?
-8.
We must write as -8. Now, your book, you might see this, the negative on the top, just for this one section. Get in the habit right in the middle and you'll never go wrong. Could you do that all by yourself? So you do have to be able to read and understand whether it's going up or going down, or going left or going right. You earn $15. Do you think that's positive 15 or negative 15? Why not negative?
Because you earned it.
Right. Earning is something you receive, right? Julie? Yeah, and are you talking about, do you want me to put the degree symbol, or you could, it wouldn't be bad, right? But what is really, I believe the question you're asking, how do you write the directed number? Yeah, so plus a 15, yeah.
If it says 15 kilometers to the west, does that mean?
Well, we'll get there in a second. All right, you spend $20.
-20.
You spend $20. What do you think?
-20.
-20, because you're losing money. You spend it, right? Who's lost on this? I don't forget how many I gave you of these for homework. How many are doing them? All right, I gave you a couple of these. All right, let's do these really quickly in your class. 5 steps down. What are we going to write?
-5.
No more. You're too quick.
Well, I can-
All right, 190 meters above sea level. Okay. Ooh, this is hard. A receipt of 85. What's a receipt?
It's what you buy.
No, it's a state of what you buy.
I put 85. Now, I think this is a poorly written question. I use the examples from the book because what Tristan just said makes sense. You get a receipt you just spent, like the cashier gives you a receipt. They were trying to say, well, what if you were the cashier, right? They get a copy of that. That's also called a receipt. So it kind of depends. If you're the business, those receipts would be positive, right? All right, this is the other weird one. All right, let's think about a number line. And let's think about east and west. What would be negative, east or west?
I don't know the direction.
Never eat soggy waffles. Start at the top and go clockwise.
So that's west.
Yeah, that's west, Jody. Right in front of us is west.
So
Somehow.
that's
Negative.
15, right?
West.
Never eat soggy waffles. So west would be what? Negative or positive? North would be positive or negative, right? Because we're going up. South would be going down. Does that make sense? Okay. You're like, how is that a math thing? You'll actually see that when you take pre-calculus. All right. Comparing numbers. I will insult your intelligence one more time today. I'm going to give you 2 numbers and ask you to use math gang symbols, right? You guys know what the math gang symbols are?
Gang.
Right? Right? So those symbols, what am I showing you?
Alligator.
I'm showing you inequalities. Right? Inequalities. I will give you 2 numbers and ask you to use an inequality symbol. Yes, I am insult your intelligence. This is not an Algebra 1 skill. This is 4th or 5th grade. The opening of the inequality always points to what? The bigger or the smaller number? The opening, back 4th grade, alligator mouth, always points to the bigger number. Which one is bigger, 3 or -3?
3.
So what symbol am I going to put here?
Alligator muscle.
I will have 9th graders that still can't tell me what that symbol is.
Alligator mouth. You're on the wrong way.
Is that less than?
Or that.
I don't know.
I will have 9th graders that still, they can write this, but they can't tell me what that is.
Exactly. Greater than.
We read from left to right. Am I coming to the mouth or the point?
No.
If you come to the mouth, that's greater than. If you come to the point, that's less than.
Okay.
So when they're not equal, we need to put an inequality. Those are your choices. We also have less than or equal to or greater than or equal to. So tonight for homework, they're going to give you 2 numbers. Here's the kicker. You can write them in any order and still be correct. Some people might want to write 7, 3. Some people might want to write 3 and 7. Depending upon how you write it will be depending upon your inequality. But the rule of the opening points to the biggest number stays the same. Which number's bigger, 7 or 3?
7.
So that inequality. Who's lost? Did I insult your intelligence?
So much.
Heck yes, I should have.
No.
All right. all of you should be able to do that with no prompting from me.
So if you know some people don't even know the rest of like it.
All right.
I call it algebra.
We okay?
On my team.
All right. Occasionally, if some student makes a mistake, guess which one they make a mistake on?
Greater than
Negative.
When both numbers are negative. So here's the paradox of negative numbers. As the number increases, hold on. As the number increases, what happens to its value if it's negative? It decreases. It's a paradox. As the number increases, -5, -6, -7, the value is actually decreasing. Please stop backing up. Let me finish. All right, we will skip that box and move on to the last idea. Here we go. We got 2 minutes. We can do this. All right, quiet, please. Waiting on you. Lunch begins as soon as we're done. All right. This looks weird. You may not remember this from pre-algebra, right? A letter that's capitalized next to a set of parentheses does not mean A times 4. If it's lowercase, it does. This means point A. Point A has what coordinate?
4.
So guess what I'm really asking you to do? Put 4 on a number line and put a dot on it. What does this say? Put -2 on a number line and put a dot and label it
B.
Okay.
I already did it.
See what I did? See what I did?
Mind blowing.
Now, your number line doesn't, I just copied from the internet. Your number line doesn't have to be as intricate as mine. All right. Which is the hardest one up here?
C
A
and
half,
D.
C.
C and D. So where is a half always?
In the middle.
If you're going to make a mistake, guess which one is your mistake going to be on?
D.
Why D?
Because it's negative.
So here's, you got to put your thinking cap on. -4.5 is between what two numbers?
-4, -4.
So it's between these two numbers. If you make a mistake, I'll see it all the time. They'll want to put it right here. That's -3.5. Okay? So when you put your values, make sure you do them correctly. Who's got questions? Can you do this by yourself?
Oh yeah.
All right. Homework will also ask you to do one more thing. Listen, please. That's literally it. They will give you the numbers. You're listening? I don't think you are. They will give you numbers and ask you what's the letter. So they will give you -2. Guess what they want you to write? They will give you 2.5, and you're supposed to write C. You can take it from there. Okay. Pack it up. Let's eat lunch.
How bad is my iron?
I know. If you had not told me, I would not know. And it's not watering, so. Yeah.
The other study, I mean,
So-
there is,
Yeah, today.
yeah, today.
Oh, that's good. I'm
My
happy.
food is never.
Come after school in here and get your testing.
If you
or-
want to, sure.
Yeah, so, what's the pickup time, like after
Let's say 4 o'clock.
4 o'clock? And I come here right after school ends? Okay,
Yeah.
thank you. Can I go put these away?
Jeez.
Sure. Yes.
Me and Piper are planning on having staying after school.
Yeah, she just asked the same thing. Yeah. So just show up right after school.
As soon as school is over, we come over here.
Yeah.
I have a candy somewhere.
All right, e-learners. Hopefully you understood that. If you have any questions, send me an email. And if not, I will see you guys tomorrow.
Bye.
Bye, e-learners.